Hello. In this video, I will try to talk about the trigonometric substitution. Trigonometric substitution is another integration technique that will help us to simplify the integrand and eventually get easily the antiderivative. Okay, let's look at that integral. We know that this is known formula is direct antiderivatives because integral of 1 over quantity square root of 1 minus x squared dx is equal to arc sine of x, or in general inverse sine of x. Of course, we have to keep in mind the domain because for the one-to-one function. And why we know this? Because derivative of arc sine of x is 1 over square root of quantity 1 minus x squared. That's what we learn this way. But what I will do, I will try to prove that this is correct, antiderivative, using actually the trig substitution. That means what is trigonometric substitution? In trigonometric substitution, we still substitute, but what we do something opposite to the u substitution. In the u substitution, we will let u to be expression in terms of x, maybe part of the integrand or slightly modified. Here, we will actually let x to be equal to some different function. And the function will be trigonometric function, of course, in terms of theta. That means in this situation, I will let x to be sine theta. And I can maybe tell you, I have the summary on the next page, but we will have three cases. We can let x to be sine theta, tangent theta, or secant theta. Okay, that's always pay attention and we will see. Here it's sine theta. Let's see why. Okay, that means when x is sine theta, I also have to evaluate derivative dx. dx is derivative of sine theta is cosine theta d theta, because I will try to rewrite the entire integral in terms of theta. Let's see, let's substitute. 1 minus x squared becomes 1 minus sine squared theta, and dx is cosine theta d theta. That means that was dx. I did replace it, dx, cosine theta d theta. And now we have this integral. Looks still maybe complicated, but we may notice that in the denominator, the quantity 1 minus sine squared theta can be compressed to cosine squared theta. We know Pythagorean identity. Sine squared theta plus cosine squared theta equals to 1. When we solve for cosine squared, it's 1 minus sine. Now, having an expression square root and squared, we can simply cancel them out, simplify it, and we will just end up with cosine. With this, what I just did with the square root, we have to be careful because when we have an expression squared inside the square root, we may say is a only if a is positive, okay, or equals to 0. Because if a is negative, like for instance, negative 5 squared, then we will not copy negative 5. We can still copy the quantity, but this quantity is negative, then we will make it positive. I will make it positive. That we have to be careful. But in this situation, because the inverse trigonometric functions are involved, we will always keep the domain. And we may notice this domain works perfect for us. Can maybe draw here because cosine function looks like this. Yes, this is pi over 2, 3 pi over 2, x, y. This is cosine of x. And we may notice between negative pi over 2 and positive pi over 2, function is above the x-axis is positive. That means cosine is positive. We may simplify like this without any negative values or absolute value. Because in general, let me actually write this. If we have a squared, we can copy a, but always positive. Then is for all real numbers. Okay, but that's not, let's come back to the substitution. That's we can see. we managed to simplify through this trigonometric substitution. We simplify to cosine theta over cosine theta, which is 1. Everybody knows what is integral of 1 d theta is just theta plus the constant. And this is almost the final answer because we did start with the x variables. We have to finish the final answer. We have to rewrite in terms of x. That means we will get back to the substitution. Sine theta was x, then theta will be inverse sine of x. We know that inverse function notation. That means theta is inverse sine of course, we may say arc sine of x. That means yes, we prove it through this trigonometric substitution. That means now, when we will see some square root expression of 1 minus x squared, and if the basic u substitution is not working, please remember about the trig substitution, sine theta. Okay, that means in general, trigonometric substitution means that we will take x, okay, and defined as a function of theta. X will be a new function with respect to theta. Then dx is the derivative of function with in terms of theta, d theta. So we can see x will be replaced with the new function, and dx, of course, is the derivative. And we call inverse substitution because we're not letting theta to be x expression. We actually saying x is in terms of theta. And as I mentioned, these three functions, this g of theta, this trigonometric function can have three options: sine theta, tangent theta, secant theta. And let's look closely, 1, 2, and 3. And we will try to solve three integrals here in this session. And you can, of course, working with me independently. Okay, that's now let's see what we did. We actually did an example with 1. I mean, we didn't do the second and third, but okay, that means square root of 1 minus x squared. And we get the substitute, we put the substitution x equals to sine theta. And we know why, because when we see 1 minus x squared, we may imagine that it will be nice if we will see 1 minus sine squared theta. And especially this is sitting under the square root, and we may simplify to cosine theta, just what we did. That means this is the main reason. Now, when we will see quantity 1 plus x squared, we may think about 1 plus tangent square. We may think about this identity like this, because 1 plus tangent square theta is secant square theta. And when we have in our integral square root, we may simplify to this. Of course, the domain is letting us to simplify it with any like negative or positive, like any absolute value. Okay, and the last form is x squared minus 1. We may think about secant square theta minus 1. When we put the square root, it's tangent square theta, and we may simplify to tangent theta. And as soon as we simplify, we will remove this square root, then hopefully it's simpler trigonometric integral. And we know trigonometric integrals, we went through those. Okay, but one thing, of course, one extra step up. We will not always have 1 minus x squared, 1 plus x squared minus 1. We may have another quantity. And I name this quantity like a squared, because for instance, when we will see 9, then we have to include this because we will square this quantity. We can see we will square it. And that 1 will be not 1, it will be 9. That's we also have to square a number to get 9, which is 3. We have to, let's say 16. We have to square the number to get 16. It will be 4 tangent. And we have to, let's say 25. We have to square a number 5 to get 25, and then of course do some algebra. That means always, yes, remember when it's not 1, we have to think about the perfect square. That means in general, when this is a squared, we will simply put a as a coefficient of the particular trigonometric function. Okay, we know everything. Now let's get ready. Remember these identities. Yes, they are really helpful. And also in the previous section, I think it's 7.2, I also put in the notes all of the identities that you need for the trigonometric integrals, that we may also need this. Okay, but everything is included in the notes. You don't have to search outside. Okay, let's see. Exercise number 1. Evaluate the integral of square root of the quantity 1 minus x squared over x squared dx. Always we have to be careful because maybe the u substitution will work. For instance, when we will have integral like this and maybe just x, we can see this is good for the u substitution. Just the u substitution. However, since we're seeing the square root, we can also apply the trigonometric substitution. Okay, that's either way will work. Actually, let me come back for a second. I just want to say one thing, because we will use trigonometric substitution if we see these expressions. A squared minus x squared, a squared plus x squared minus a squared. And especially when we see them inside the square root. But sometimes we may see two things. One thing is that we may see this square root not, hidden in the exponent as a rational exponent. That means we may have this quantity rise to the power of 1/2. It's also square root. That's we may still think about the trig substitution. We may even have additional power, 3/2. That means 3/2 means that it is square root and everything is cube. It's still good. Or we may have even without the square root and, for instance, cube or taken to the power of 4. And then you also don't know what to do because this looks complicated. You may still try the trig substitution. Okay? That means this is typical to see the square root. But remember, if the square root is hidden or if it's not really square root, it's different power. Also, trig sub will work. Okay, now let's start working. Okay, that means this is good for the trig substitution. And we will let, of course, x to be sine theta because it's 1 minus x squared and only 1. dx is cosine theta d theta. Let's replace everything. X is sine theta, and dx is cosine theta d theta. Of course, I squared. And now we can see in the denominator, numerator, the square root expression, 1 minus, where is my, let's do the pointer maybe this way. Oh, no. Okay. 1 minus sine square theta, it's I did rewrite as a cosine square theta. Now the square root and square can be cancelled out. It's just cosine theta. We did manage to rewrite without the square root. Cosine times cosine is cosine square theta. Okay, well, we end up with the trigonometric integral, and I hope it's not difficult. What we can do? We may rewrite cosine square theta as a sine square theta as a cotangent. But I don't know if this is helpful. Maybe, or we may rewrite as a 1 minus sine square theta because we have to do something. We have to integrate. And now, because cotangent square theta has formula, yes, cotangent square theta is equal to, and we may see what I just added, 1 over sine square theta is cosecant square theta, minus sine square theta over sine square theta is 1. That means if you don't know cotangent, you can rewrite as a 1 over, let me maybe, we can see that's another, this will be 1 over sine square theta minus sine square over sine square theta d theta. Yeah, that's from this. So you may skip that cotangent if this is too many formulas. However, the previous notes includes that. Okay, and 1 over sine cosecant, sine over sine 1. Okay, that's me now. I think it's easy because integral of cosecant square theta is just negative cotangent theta. Integral of 1 d theta is theta. Okay, we manage. We have the integral in terms of theta. But now, we have to get that answer in terms of x, the original variable. That's we know how to write theta. If x equals to sine theta, theta will be inverse sine of x, or if we prefer, arc sine of x. That's okay. Now, cotangent, we need that ratio. That's what we will do. We will use the same substitution. Sine theta is x. I can rewrite as a ratio. Sine theta is x over 1. And now the right triangle will help me, or just the identities, but right triangle is a nice tool to see the trig identities. I will put the ratio in the right triangle. That means sine theta is opposite over hypotenuse. X over 1, because it's x opposite, 1 is hypotenuse. If the opposite is x, hypotenuse is 1, using the Pythagorean theorem, I can compute the third side. A squared plus b squared equals to c squared. 1 squared minus x squared square root. Okay? And when we have the right triangle, the solved right triangle, I can read any ratio. That means cotangent theta is adjacent over opposite. That means cotangent theta will be square root of 1 minus x squared over x. And when we substitute, is here. That means the last step, is the final answer. Okay? That's it. Please remember, use the triangle to get the other ratios, because one of the ratio will be in the substitution that you choose, and if one trigonometric ratio is given, we can get the rest of them. And of course, the inverse function. Okay, that's we did one. Now I have the exercise for you. That's your turn, exactly the same way, but what you will do, the trigonometric substitution, we can see 49 minus x squared, 7 sine theta. And then find dx and start from there. Okay, I will leave it for you. You can check the solution in the notes. I also have this one as a multiple choice. You can also easily solve, and I will not tell you the substitution. And I also have this one. This one is a little bit challenge. Actually, it's solved. You may cover the solution and you can look, but let's see what I did. I completed the square in that square root expression, because square root expression. And if I let u to be 1 plus x squared, we will end up with this integral. And from now, you know that is the 2 sine theta and so on. Please cover the solution and do it on your own, please. Okay, now, exercise number 2. As I promised, we will solve 3 integrals, or maybe 4. Okay, you can always pause the video and come back later. Okay, now we have the integral 1 over x squared and square root of the quantity x squared plus 4. Okay, now we know that the substitution will be tangent theta, because it's x squared plus the quantity. And coefficient 2. That's we have x equals to 2 tangent theta dx 2 secant square theta d theta. Okay. Let's substitute everything. that's d theta, I mean dx, I square x squared, I mean I squared x, which is 2 tangent, 4 tangent square. I squared x, again, I squared 2 tangent, 4 tangent square theta plus 4, and that's dx, 2 secant square theta d theta. Okay. Yeah, we may simplify a little bit. However, the main point is to simplify that square root. That's maybe I can write here 4 tangent square theta plus 4. And now we can see we needed that extra coefficient too, because we may factor out 4 tangent square theta plus 1. When we have product, we can split for 2, and tangent square theta plus 1 is secant square theta. Square root of 4 is 2, square root of secant square theta is just secant. Okay, that's we may rewrite as a 2 secant theta. Beautiful. And now a little bit of simplification. We can simplify this square and this. Okay, that's we end up with, even better, 2 and 2, 1, 1. Okay, that means 1/4 stays, 1 secant stay, and tangent square theta stay. Another trigonometric integral. Let's rewrite this integral in terms of sine and cosine. That means when I rewrite this 1/4, secant is 1 over cosine theta, tangent square is sine square theta over cosine square theta, d theta. And when we flip, cancel out one of the cosine theta over sine square theta. And another trigonometric integral, but I think this one is easy to realize, that is u substitution. We will let u to be sine theta, yeah, we can see I typed in the corner, and then cosine theta d theta is just du, 1 over u squared du. Integral of 1 over u squared is negative 1 over u, and yes, plus the constant c. This is the answer in terms of u. Now let's get back. Instead of u, get back to the x variable. U is sine theta. That means I put theta. And now sine theta in terms of x. Let's look at the substitution. We did have the substitution that tangent theta is x over 2. Let's build the right triangle. For the other ratio, we need sine. Tangent is opposite to adjacent. Okay, x over 2. If this is x, this is 2, hypotenuse will be x squared plus 2 squared, square root. And now we can read, actually 1 over sine is secant, but okay, let's read sine theta. Sine theta is opposite to hypotenuse. And 1 over sine theta, which is actually cosecant, we can just flip it. That means square root of x squared plus 4 over x. Let's substitute. We keeping 4 and we keeping that negative. That means this is the final answer that we have to provide in terms of x. Okay, that's what we can see. Lots of simplification, and which is constant gratification. It's really satisfying. And then we still have the trigonometric integral, but we can manage. Okay, beautiful. We did tangent. And maybe let's do one more tangent and then secant. This one you can do easily. Oh, actually, really nice. You can do trig substitution. Okay, you can check in the notes. 2 times tangent theta. And of course you can, or this one is just good for the u substitution. If we will let u to be the inner function and du is waiting for us. That's you can do both ways and see if you will get the same answer. You have to get the same answer. Yeah? It's good, yeah, good example. And actually it's even the definite integral. We have limits of integration. But check the indefinite, check the general antiderivative. Okay, good practice. And oh, I have also this one you can try. Okay, because also involves, we can see x squared plus, that means it will be tangent. Okay, this one I can maybe initiate, or we can solve it. Let's maybe solve it. Again, if the video is too long, you can get a break. Let's actually solve it, because we don't have to completely solve it. We have to just rewrite in terms of theta integral. Because what worries me, that 9. Yeah. Everything what I was like showing you, like how we can apply the trigonometric substitution, was 1x squared plus a number, or a number minus 1x squared, or 1x squared minus a number. That's mean we didn't have a coefficient different. That's mean I will first of all, since we don't like the coefficient 9, let's factor out. Let's factor out that 9. That means I am factoring out 9. We will have x squared plus 16 over 9. Okay. Let me write x squared and then square root of 9, square root of x squared plus 16 over 9. So we can see now x squared plus 16 over 9. We will let x to be 4/3, of course, tangent theta. And dx is 4/3 secant squared theta d theta. Let's try to see what we will have. This is, okay, I will do step by step. X squared will be 4/3 squared tangent squared theta. Square root of 9 is 3. And this one will be, let me square it, 16, 9, because I have to square x, and x is 4/3 tangent. 16, 9 tangent square theta plus 69. Okay. And dx, dx is 4/3 secant square theta d theta. I almost forgot dx, which actually is a common mistake, but no, I didn't. Okay, that's what we can do. Let's maybe start I can cancel out 4/3 and squared. And for now, that's it. Oh, okay, no, let me rewrite. That's we will have secant square theta. This will be 4/3 times 3 tangent square theta. And the denominator, let's maybe simplify a little bit faster. We may factor out this, and then we will have tangent square theta plus 1. Okay, tangent square theta plus 1 is secant square theta. Secant square theta. And now square root of 16 ninth is 4/3, and square root of secant square theta is just secant theta. So let me rewrite this. It will be nice. 4/3, and square root of secant square is just secant theta. Okay, it means now we can cancel that secant and this one. We can cancel this one. 4 times, that's what we have, because we have to get is 1 secant on the top, tangent square theta, and then the constant is, this is 4, and this is 4/3, which is 16/3, but when we flip it, because it's in the denominator, 3/16. D theta, let's get the final integrand. Secant over tangent square, 1 over cosine, And tangent is sine squared theta over cosine squared theta. Cosine can cancel out. Cosine. Oh, sine. Sine. Did I say secant? Tangent, of course, is sine over cosine. Sine square theta over cosine. Okay, that means this will be the final answer. Cosine theta over sine square theta. And I hope, yes, we do have this option. Luckily, we don't have to integrate, but it will be easy U substitution. Okay, but what I just wanted to show you that 9, okay, that coefficient, please make sure that we have 1x squared. Oh, we may still maybe do a couple of different algebra steps, but let's do, yes, at least this way. Okay, we did it. I hope this is the correct answer. Okay, and now I have another one, but I can leave it for you. And we may see the quantity 1 plus x squared is raised to the power of 3/2. That's we know that this is hidden. 1 plus x squared, 3/2 is square root. You can simplify and still keep the cube. And that's you will do the substitution tangent theta and go from there. Okay. And okay, I also have this one. This one is interesting. Let's maybe do it. Okay, and then we will do one secant and we will be done. Because this one is, again, square root and quadratic expression. We don't see directly like x squared plus a number, or maybe number plus minus x squared, or x squared minus a number, but we see quadratic expression. That means we know what to do. We have to complete the square. We will have x squared plus 6x plus 9, because 6 divided by 2, 3, 3 squared is 9, and then the missing number is 4 to get 13. Okay. And then we can see we have x plus 3 squared plus 4. X plus 3. Okay, and now when we will do the u substitution, x plus 3, just the linear, du is dx. We have no problem. The integral looks like u squared plus 4 over u, and this is still square root. Du is dx. Okay, and now that was the point. Now we can apply for this one. Let's maybe start here. We can let u, because u is the independent variable, to be 2 tangent theta. 2 tangent theta. Okay, then du is 2 secant square theta d theta. You can see this is the trig substitution. And let's see what we have. We will have 4 tangent square theta plus 4 square root over u. U is 2 tangent theta. Okay. And when we simplify, we can factor out 4. Square root of 4 is 2. And then we will have tangent square plus 1. Tangent square plus 1 is secant square. Secant square and the square root is just secant. Good. And when we simplify secant over tangent, it's just sine, I think, sine theta, because this one will be 1 over cosine, sine over cosine, of course, theta. That's we can cancel out. Oh, it's actually 1 over. No. 1 over cosine, sine over cosine. When we flip, it's 1 over sine. 1 over sine theta d theta. Oh, and this is cosecant theta. That's let's leave it, because this is another, let's see, and because we have to just leave it in terms of theta. That's good, actually. Because it is, not bad. But we can leave it this. You can do it. You can still do it. But we will not talk about this because then we will lose the main point, the trigonometric substitution. But what was my point? My point was that you may do it, that form you can change for the completing the square. That means you may still end up with this form that we just learned. Okay, really nice, but let's leave it. Yes, actually, that's the instruction. I'm gonna keep the instruction. Okay, and let's do one more. Let's do this one. Integral of quantity under the square root, x squared minus 25 over x cubed dx. Okay, that means this is definitely x squared minus 25, positive x squared, 1 when we don't have additional coefficient. Okay, then the substitution is 5 secant theta. This is supposed to be 5. Okay, 5 secant theta because it's minus the quantity, minus the constant. And then derivative of secant is secant tangent. Okay, secant theta, tangent theta. And 5 because we do have coefficient 5. We need that 5 to be factored out later. Okay, that's mean now let's substitute. X square root, x squared. I will square x, which will be 25 secant squared theta minus 25. Okay, and then x cubed will be 5 cubed secant cube, and dx is 5 secant theta tan theta d theta. You can work along with me. Now we can simplify a little bit. Squared 1 squared. Okay. Oh, of course, square root. We may factor out 25. Square root. When it's product, we can split for 2 square root. And then secant square theta minus 1. Okay. This one will be 25. This one is secant square and tan theta d theta. Okay. What we have, this is 5, this is 25. Secant square theta, tan theta, d theta. Okay, secant square theta minus 1 is tangent square. Yes, that means this is inside is tangent square. Let me maybe put tangent square theta, but tangent square theta under the square root is just tangent. Okay, that means this is just tangent. I can maybe, this will be 1/5 when we simplify. Tangent theta over secant square theta. And another tangent, I can put square. Okay, I hope we good. Now, when we rewrite in terms of sine and cosine again, sine square over cosine and 1 over cosine. Okay, we will just end up with sine square theta d theta. Let me write this. Tangent is sine square theta over cosine square theta. Secant square is 1 over cosine square theta. And when we flip, we will cancel out. Now, sine square theta. Okay, another important integral. We learned in the previous section that sine square, we may use the half angle formula, 1 minus cosine of 2 theta over 2. Okay, quite important. Okay, let's rewrite. 1/2 I can put in front, 2 times 5 is 10, and 1 minus cosine of 2 theta, d theta, 1/10. Integral of 1 d theta is theta. Integral of cosine 2 theta is positive sine of 2 theta over 2. Okay, we did it. The only thing, we will not get the sine of 2 theta. We have to rewrite this. We will rewrite using the double angle formula, because 2 theta, like we can know sine of 30, but let's say we will know sine of like sine of let's say 70 maybe will be given, but how I can use that value to have sine of 40. Yeah, that's different, yes, different story. We know, yes, we know double angle is not the same as single. That's mean, but we know the formula. Sine of 2 theta is equal to 2 sine of single theta times cosine of single theta. We can cancel out. That's mean what we need. We need theta, and we need sine theta and cosine theta. Now we can use the triangle and get the ratio, but we will not get sine of 2 theta. Okay, what was the substitution? Substitution was x equal to 5 secant theta. That means secant theta equals to x over 5. Let's build the triangle. This is theta. Secant is reciprocal of cosine. That means it will be hypotenuse over adjacent, because cosine is 5 over x, correct? And then, oh, no, hypotenuse over adjacent, okay. And then to compute the third side, we will use the Pythagorean theorem, a squared plus b squared equals to c squared, x squared minus 25. And we, of course, recognize wherever and whenever we were calculating the third side, that square root looks identical like in the original integrand. Okay, let's come back. Let's see. Okay, and we need sine. That means sine theta will be opposite over hypotenuse, and cosine theta is just the flip of secant, which is, of course, adjacent to the hypotenuse. And theta will be arc secant of x over 5, yes, from here. Okay, we have everything. Let's write down the final answer. Theta is arc secant, because that was the substitution, of x over 5. Sine, let me prepare, is x squared minus 25 square root over x, and cosine is 5 over x. Let's put x squared. And 5 we're supposed to put in front. Okay, that's the final answer. I hope you enjoyed the trig substitution. We know that we have 3 options: sine theta, tangent theta, and secant theta. Know the corresponding trigonometric identities, know how to simplify, and then it's a pleasure to actually integrate these beautiful integrals. Let's look at this one and this one. Let me box the final answer, and that's it for this section. Please enjoy, please solve all of the problems. You can check the notes. I also have this integral for you, secant, and this one. Okay, really nice. Try. All of the solutions are placed in my notes, but check them and solve all of the integrals independently. Thank you.